I'm going to teach you how to calculate the empirical formula of a compound given the percent composition. A compound contains 95.71% silicon and 4.29% hydrogen. What is the empirical formula of this compound? First step, you're going to convert the percentages to mass. Out of 100 grams, 95.71 grams would be silicon, and 4.29 grams would be hydrogen. You're going to convert now the grams to moles by dividing by their molar masses. On the periodic table, the mass for 1 mole of silicon is 28.085 grams of silicon per 1 mole of silicon. The molar mass of hydrogen is 1.008 grams of hydrogen per 1 mole of hydrogen. Okay, grams cancel, and you now have moles of each once you do this calculation. So 95.71 divided by 28.085, you get 3.41 moles of silicon. And 4.29 divided by 1.008, you have 4.26 moles of hydrogen. Next step, you're going to divide by the least amount of moles between the two. Divide each by the least amount of moles, which is 3.41. This is equal to 1. And if you divide this by 3.41, you get 1.25. Okay, so this should give you the ratio of moles of silicon to moles of hydrogen, but you should not have the ratio that has a decimal. And so you're going to multiply by the lowest whole number that will give you whole numbers. So 4, you would multiply both by 4. And so for every 4 atoms of silicon, there's 5 hydrogen atoms. And so the empirical formula for this compound is Si4H5. Let's do another problem. Find the empirical formula for a compound that contains 36.5% sodium, 25.4% sulfur, and 38.1% oxygen. So out of 100 grams, there would be 36.5 grams of sodium, 25.4 grams of sulfur, and 38.1 grams of oxygen. Now you're going to divide each by its molar mass on the periodic table. The molar mass of sodium is 22.990 grams of sodium per 1 mole of sodium. The molar mass of sulfur is 32.06 grams of sulfur per 1 mole of sulfur. And the molar mass of oxygen is 0.999 grams of oxygen per 1 mole of oxygen. Okay, so the moles of sodium is 1.59 moles of sodium. Moles of sulfur, 25.4 divided by 32.06, and you get 0.792 moles of sulfur. The moles of oxygen, 38.1, divide that by 15.999, and you get 2.38 moles of oxygen. Now you divide each of the moles by the least amount of moles, which is 0.792. So 1.59, divide that by 0.792, you get 2. 0.792 divided by 0.792 is equal to 1. And 2.38 divided by 0.792, that's equal to 3. And so the empirical formula for this compound is Na2S1 and O3. Let's do one more practice problem. Calculate the empirical formula of a compound that contains 50.04% carbon, 5.59% hydrogen, and 44.37% oxygen by mass. Okay, I want you to pause the video and try to solve this on your own. Did you get it? The empirical formula of this compound is C3H4O2. Thanks for watching. Click the link in my subscription to get my free guide on how to achieve success in chemistry. Like and subscribe for more chemistry videos.